Hey everybody, it's time to talk about our last topic in Unit 6, Techniques of Integration. It was a long unit, but it's such an important unit because you're going to need integration techniques for the rest of your math career and physics career and chemistry career and biology career and all of your STEM stuff. Because you're going to need to do all these integrals and you're going to need to know what the integrals mean and how to deal with them with all of these techniques that I told you. And you're going to learn some more techniques in advanced calculus courses. This doesn't mean multivariable. This is actually still for single variable. You'll learn about Feynman integration. You'll probably learn about residues and complex analysis, which could be applied to real integrals, but that's besides the point. We are starting improper integrals today, and this is a topic that is completely dedicated for BC students if you're taking the AP exam, or it's part of every Calc 2 career, as it were. So we're going to be dealing with improper integrals today, and this is really going to be where Unit 1 meets Unit 6, because we're going to be going back to limits, our roots in calculus. Let's get started. So continuity. What do we remember about continuity? So if you remember continuity, you remember kind of the simpleton's definition is, can I draw the graph without picking up my pencil? Is that possible? So for a rule of thumb, here's an example of a continuous function. Here we have x cubed, or some third order polynomial. You can see that is a continuous function. But we also have discontinuous functions. Here's a discontinuous function. And this has asymptotes everywhere. It might have a couple of holes. So that's a discontinuous function. Now, what we want to deal with in improper integrals is how we integrate over discontinuous functions like this. Now, you remember how we have holes and jumps, right? So holes and jumps can be dealt with pretty easily, right, with integration. So say I have a hole, right, in my function, and then I want to integrate over it. Well, in that case, I can take the limit and I can just find the value of the limit at the hole, and then it's fine. Or if I have a jump, like this, then maybe I go to a quadratic down here. Well, what I can do is I just divide it. So I integrate this part, and then I integrate that part, and then we just add them up. That's easy. But asymptotes are a little bit harder. So what we want to deal with improper integrals is when we have something infinite inside of the integral. This is going to sound a little bit weird, but let's look at asymptotes again. So if I have a function that has asymptotes in it, how am I going to deal with integrating it? So yeah, this is an issue because we are going to need to employ some new techniques. So that's kind of the deal with improper integrals. So we look first at integrals over infinite regions. So say I tell you to integrate, I don't know, 1 over x or something, and I want you to integrate that between 0 and, or 1 and infinity. So if I tell you to integrate that between 1 and infinity, well, we're going to be left with an integral that has infinity inside of our bounds. So what we do to remedy this, because if you have infinity in your integral bounds, your teacher is like going to throw up. They're going to hate that. You're going to want to rewrite this as the limit as a variable, I don't care which variable you choose, t approaches infinity, of the integral between 1 and t of dx over x. Okay, and then you can do that. Then that's fairly simple. You would evaluate that out. But we're going to be talking about that in the next video. We're going to be doing two videos. So first we're going to talk about integrals over infinite regions. And then we're going to talk about integrals over functions with vertical asymptotes. So say we have like this guy here. If I have 1 over x still, right? So say I have 1 over x, and I want you to integrate this whole thing. And I want you to integrate all of that, or I want you to integrate a function that looks like that, like this here. if I want you to deal with that, how do you integrate? So I want to get that there, then I'm going to get that there, I want to get that there. How do we do that? Well, that's what we're going to be talking about in the second video, which will